This is my answer for homework number 9, question 1. The question says that W of t is a stochastic process with the expectation of W of t equaling 0, or the mean, and the autocorrelation of T1, T2 is equal to alpha times the minimum of T1 and T2. So the first part of the question says define that Y of t is equal to Wt minus W of t minus 1 for t is greater than or equal to 1, and is 0 for t is less than 1, so basically 0 in all other cases. So I did that right away and basically just rewrote it as Y of t is equal to this piecewise function where W of t minus W of t minus 1 is, or that's the case when t is greater than or equal to 1, or 0 when t is less than 1. So next part of the question says find E of Y of t and the autocorrelation of T1, T2. And the last part of the question is asking if Y of t is a wide-sense stationary process. So to find E of Y of t, we rewrite E of Y of t is equal to E of Wt minus W of t minus 1. And we can expand that, so that's E of W of t minus E of W of t minus 1. So here we were given that E of W of t is equal to 0, and so that means that the expectation is essentially, because it's a constant, it's independent of t, and so that means that, well, we've already been given that E of W of t is 0, but that also means that E of W of t minus 1 is also 0. So you get 0 minus 0, which is just 0. So the next part, to find the autocorrelation, we were given, this is what we were given, so we were given that R of W of T1, T2 is equal to alpha times the minimum of T1, T2, and we're looking for R of Y of T1, T2. And so R of Y of T1, T2 is just the expectation of YT1 times YT2, and that's where we can plug in the T1 into our function that we were given. So we have E of Wt1 minus Wt1 minus 1, and then we're multiplying that by the T2 plug-in, so that's times Wt2 minus W of T2 minus 1. And from there we expand, so we have the expectation of Wt1 times Wt2, so you just FOIL it, minus Wt1 times Wt2 minus 1, minus Wt2 times Wt1 minus 1, plus, because we have two negatives, Wt1 minus 1 times Wt2 minus 1. And so the expectation of Wt1 times Wt2 is the alpha of, so basically I took out I factored out the alpha, because alpha is just going to be multiplied all the way through for each of these pieces. So we have alpha times the minimum of T1, T2, so that's essentially what just this chunk is, and then minus alpha times the minimum of T1, T2 minus 1, minus alpha times the minimum of T1 minus 1, T2. So I rearranged that there a little bit. And then the alpha times T1 minus 1, alpha times the minimum of T1 to minus 1, T2 minus 1. And so we set up 4 conditions. So the first condition is that for T1 is less than T2, and T1 minus T2 is less than 1, we have that the autocorrelation is equal to 0. And then for the next condition, where we still keep T1 is less than T2, but this time for T1 minus T2 is greater than 1, we end up that the autocorrelation is alpha times 1 minus T2 minus T1. For the next condition, we have T2 is greater than T1, and T2 minus T1 is less than 1. So similar to the first condition, you end up with autocorrelation is equal to 0. And then for the last condition, for T2 is greater than T1, but T2 minus T1 is greater than 1, you end up that the autocorrelation is alpha times 1 minus, and this time they're in reverse, so it's 1 minus T1 minus T2. Another way to write this is in a piecewise function. So we have for the autocorrelation T1 minus T2, sorry, T1, T2 is equal to 0 when, so we have 0 for basically T1 minus T2 is less than 1 and T2 minus T1 is less than 1. And so essentially that's just the absolute value of T1 minus T2 is greater than 1. And then for all other cases, so when T1 minus T2, the absolute value is less than 1, we have alpha times 1 minus the absolute value of T1 minus T2. And the absolute value of T1 minus T2, that's just equal to tau, which means that y of t is dependent on tau and not necessarily dependent on anything else. And so because autocorrelation is only dependent on tau, not y of t, but the autocorrelation. So because it's only dependent on tau, we have a wide sense stationary process.